Hi, good evening, everybody. My name is Ling. I'm a senior integration consultant and have been working at Capgemini for 6 years now, with a strong focus on Oracle Fusion Middleware and Oracle Integration Cloud. All right. In the next session, I will be exploring the following subjects with you. First, I will give a brief technical introduction of our use case, which was an actual use case by a client who requested us to do a proof of concept on. And using that use case, I will cover some of the offerings that Oracle Cloud provides. Next, I will give you an overview of Oracle Integration Cloud, followed by the Autonomous Transaction Processing Database, or ATP in short, or just the Autonomous Database. It's a very interesting cloud service of Oracle, and maybe the coolest product Oracle has introduced in recent years. Then Oracle Function is on the agenda, and I'll tell you how we've been exploring this nice feature to expose data from a database in an API, entirely serverless and containerized. And lastly, I will give a demo of all the features discussed, of course. Now, let's start with the use case. As Toolkit has already elaborated, we're talking about a furniture company here, and we're here looking at a technical overview of one of their business processes. So this process kicks off when a CSV file is placed on a file server. And as we will see later in the demo, I have set up my local machine acting as the file server. On the left side, we see a sample CSV file. It is a CSV file containing information about sofas. We can see the item number, the item name, but also the sofa type ID to indicate what kind of sofa it is, and also the number of seats that sofa has. Now, that last part is very important because it's very prone to errors. Sometimes the number of seats is not correct, and as Toolkit has already said, then we cannot sell the sofa. So we have a validator built in here. So let me break this down for you. First, we have the file server where the file is placed. Then we have an integration over here that has a file adapter that pulls a location on my local machine for this file. And once the file has been picked up, it is sent to the Oracle decision model. And this decision model contains all the business rules to decide whether the content is correct or not. And if correction is needed, the file is sent to a process. And that process has a human task. And it will require an actual human, an employee, to make the correction in the file. And this process is in a purple rectangle, and that means that Viraj will be covering that subject. So after correction, the file is sent to a second integration, and this second integration has a database adapter, and that will make sure that the data is written to our autonomous database over here. Well, sometimes, of course, the file is correct entirely, then it's not necessary to send it to the process, and in that case, it will send to the second integration directly. Now, back to the database. On top of the database, we have created an extra layer called Oracle REST Data Services, also RDS in short. And this is actually a nice Java application on top of the database, and that will allow us to actually interact with the data in our database. And we will be doing this by using Oracle functions. We have written a function that uses this RDS layer to interact with the data. And then Viraj will be showing you the API Platform Cloud Service. He will show us how we can set up an API gateway to expose the API to the outside world, but also how we can do API management and create a nice developers portal using Apiary, which is acquired by Oracle some time ago. And lastly, he will also show you something of Oracle Insights, how we can make some nice, meaningful, and customizable dashboards to gain some insight in our processes. All right, on to Oracle Integration Cloud. Now, as an Oracle integration consultant who has been working with Fusion Middleware for the past 6 years, the first thing I noticed exploring OIC was how intuitive and easy to use it is. And to be honest, this is not the first time I'm looking into Oracle Integration Cloud, because a few years ago, in 2017 I followed the course for its predecessor called Oracle Integration Cloud Service back then. And I must admit that the product has matured so much especially when it comes to the UI and its ease of use. And here are some of the key offerings in my opinion. Of course, it will allow you to integrate your SaaS and on-premise applications, and it has many ready-to-use integrations with all kinds of design patterns available on the Oracle Cloud Marketplace. Some of them are freely available and some are paid. And next to that, there are many pre-built adapters available for all kinds of applications, as we will see in a bit. And what's also nice is that connectivity is provided for new technology, like artificial intelligence. You can build your own digital assistant and work with machine data. And it even provides a blockchain platform if you're interested in incorporating smart contracts in your business processes. And insight in these processes is provided by the many dashboards you can use and customize. Milestones are drag and droppable, making it easy to create dashboards for different audiences, as we will see later. And lastly, data mapping is, of course, a big part of our work as integration consultants, and especially large transformations can be a hassle sometimes. But luckily, auto mapping is a nice feature that can do most of the work for us. Now on to the next subject, that is the autonomous database. As you could have seen in the technical overview, we are actually connecting to the autonomous database in our second integration to write the data from the CSV files to the database. Now, what is that ATP database? It is a cloud database service that eliminates the complexity of operating and securing high-performance databases. The service automates things like provisioning, configuring, tuning, scaling, patching, but also repairing of databases. And that saves you lots and lots of time, because go figure, a lot of time and money is spent on tuning and patching alone. Now, the autonomous database is always free in tenancy in the cloud, and you can create as many instances as you want. And it can be serverless. That means it runs without provisioning infrastructure. And in that case, Oracle deploys and manages the Exadata infrastructure for you. And it runs in the public cloud. But it can also be on dedicated infrastructure. Then it's run on dedicated Exadata infrastructure. And the stack will then run isolated from all the tenants. And basically, it's a fully isolated cloud in a public cloud. So if you demand more security, then that might be it for you. And the database, of course, has REST API support, and Apex is also available to create web-based apps very rapidly. And it is also high performing and high available with its 99.95%. And that is like only a few minutes downtime a month. And then there are also quite some machine learning algorithms available and support for languages like Python and R, and options to create your own dashboards. All right, then on to the next subject, Oracle Functions. As I've already told, we are using Oracle Functions to gain access to our data using the ORDS layer. So what is Oracle Functions? It is a fully managed, multi-tenant, highly scalable, on-demand functions as a service platform. It is built on enterprise-grade Oracle Cloud infrastructure and is powered by the Function Project open source engine. It is serverless and has an elastic architecture and is used to focus on writing code to meet business needs. And supported languages, amongst others, are Java and Python. And the best part of it all, you are only built for the resources consumed during execution. So being an efficient coder is actually a nice trait to have. Now, what does that look like when we deploy and invoke a function? Let's start with the deploying on the left side. So using command line interface, you build a Docker image from the function, which is pushed to a Docker registry. And you always have a func.yaml, and that is basically your function definition. It describes settings like the max length of time the function is allowed to execute for, and the max amount of memory the function is allowed to consume. And together with a link to the image in a Docker registry, it is then uploaded to the function server. And then lastly, the function is added to a list of functions and then can then be seen back in the OCI console. What happens when you invoke a function? Well, that can happen in a several ways. Amongst others is via a signed request to the function's invoke endpoint. And when a function is invoked, Oracle function sends the request to the function server, which uses the function definition to identify the Docker image in the registry, and then executes the function by running the image as a container on an instance in a subnet associated with the application. And when that function has finished executing, the Docker container is removed again after a time to live period expired. But if another call is made to the same function before the container is removed, it will just use that same container, and it will scale horizontally, having multiple containers when requests are made in parallel. And as you can see, once inside the subnet, the container will have access to other OCI resources that reside in that same subnet. And in our example, it's the database. All right, now on to the demo. Let me see. First, I'm going to show... let me see. So here I have my local machine set up as the file server. As you can see, I have here the connectivity agent running, and this Java application creates a safe security connection from my local machine to the Oracle Cloud. And on the we have here some CSV files. I will be placing 2 files into this folder over here that's being pulled for my integration using a file adapter. So I will have one file that needs correction and one that doesn't. And sometimes I can say that it has disappeared, and that means it has been successfully picked up by Oracle Integration Cloud. So let's switch to Oracle Integration Cloud. Let me see. Let's drag it over here. So this is the landing page of Oracle Integration Cloud. Let me see. The first thing I want to show you are the adapters that we've been talking about. There's a very extensive libraries of all kinds of adapters available. It connects to SAP. We have Facebook over here, but also non-HTTP based endpoints like for file adapter, an FTP adapter, connects to Google, even other vendors like IBM. Of course, the big ERP system from Oracle, JD Edwards, Jira is here, LinkedIn. There are many adapters to choose from. All right, then the integrations themselves. Let me see. Here I have my furniture type file reader integration. And this is the integration that has picked up my CSV files. So we can see the file adapter over here. It's configured to read my local machine. And under the hood, this is all classic Oracle. Because if you export this and import this in your JDeveloper locally, you will find the .jca files as you're used to. And well, under the hood, it's all classic Oracle. Of course, you can also do some transformations, as we can see here. It's all in XSLT. XQuery is unfortunately not supported. So we have the designer view where we can map our data, of course, and the source view to do some more complex transformations if needed. All right, back to our integration. So after that, our decision model will be invoked over here. And that decision model will decide whether the contents of the CSV file is correct, yes or no. And if correction is required, we will get a message back from the decision model saying that the file needs correction. And in that case, the file is being sent to a process that's over here. So corrections can be done by an employee of our furniture company. Otherwise, it's sent to the second integration, which has the database adapter, so the data can be written to our autonomous database. So I've mentioned the decision model a few times now, so I'm going to show you that under processes. And this is our decision model. It has a tabular view where we can put all our business rules in. So each row represents one business rule. And basically what happens on the left side, in the gray areas, that is the input that we are receiving. And on the right side, the yellow columns are the outputs. And so when we receive the contents of the file, it is being tested against those rules. So for example, we have a sofa type ID 2 over here. And a sofa with this ID should have 1 seat. So when that's the case, then correction is not needed. So that's why there's an N over here. But if there are more or less than 1 seat, then correction is required, and then it will return to integration saying, hey, correction is needed, so send it to the process. Now, this decision model is exposed as a REST service. We can see it over here. So that means it has its own endpoint. It has a request payload and, of course, a response payload. All right. And when you are developing, or whether you're a developer or an operator, you will need to gain insight in how your integrations are doing. And we can do this here. We can do some tracking. And this is very nice to see, because here we can see that a few instances have run. As you remember, we have just put a few files in my local machine, and well, they have all succeeded. And I can open one for you. Let me see over here. Because using the instance tracking, you can see how the message has been changed step by step. And whenever there's an error, you will see that here too. So you can start with debugging. All right, so that was it for Oracle Integration Cloud. I want to move on to the autonomous database. So that is where our data is being put after correction, or no correction straight away when the files are entirely correct. This is the landing page of the autonomous database. As said, it is always free in your tenancy, and you can create as many instances as you want. So let me see. Yeah, there are many features to autonomous database. I've mentioned a few before. You can do machine learning, and ORDS is there, and SODA, which is an API-like way to create collections and procedures, and can be in different languages like Java, PL SQL, or REST. And Apex is, of course, available to create web apps. All right. I'm going to log on into the database. I will need to provide my passwords. I hope it's first time right. Fingers crossed. Okay, I think we succeeded. I'm going to start an SQL worksheet. Well, I think this looks familiar. It looks a bit like how we would do in on-premise SQL Developer, for example. And this is a simple database with one table, furniture type. And in this table, this is actually where all the data ends up. So with or without correction, it is written to this table. And using APIs, we can expose this data to the outside world. Now, it is very easy to make it REST available. You can enable REST by right-clicking the table, press enable. You can provide a few things like an alias. You can see the endpoint, and you can set authentication if needed. All right, then on to Oracle Functions. Oracle Functions. So this is the Oracle landing page for functions. And before you create a function, you will first need to create an application. And after creating that, you can create one or multiple functions. And in our case, we have created a Java and a Python function. And when you start creating a function, you can make use of the Getting Started page, for example, because it will guide you step by step how to do that, how to create, deploy, and invoke your function, for example. And let me start up the shell environment first, because this is your development environment, basically. Can take up some time. Waiting for it to load. Come on. Connecting. All right, and here we are. So this is our development environment. And when you first start, you can make use of the several samples that Oracle provides. There are many of them. I can show you. So there are Java functions, there are Python functions. And in our case, we use the OCI, ADB, ORDS, Run SQL Python. And if we look into that, we can first see, of course, the function YAML. As you may recall, this is the function definition, and you just can describe a few things. For example, the runtime, but also add extra settings for memory allocation and such. And then, of course, we have the actual code. So I have here my Python script. I hope this you can read this. Otherwise, give me a signal. But it is basically a simple piece of Python code with a several Python functions. And this function does nothing more than setting up a connection to the Oracle database and executing a select star statement to our furniture type table and returns this information afterwards. So that's it from my side. Over to Viraj, who will be covering the following subjects with you. Go ahead, Viraj.
Thanks, Ling. I will start by sharing my screen. And please let me know if you can see me and hear me. Can you see my screen? Hello. Okay, take it as yes. I'm Viraj. I work as a senior consultant with Capgemini. I was always enthusiastic about the integration platforms and technologies in general. With the evolution of iPaaS in the recent years, I've shifted my focus towards the cloud offerings from Oracle and other competing vendors as well. So in today's session, what we're trying to do is we're trying to introduce to you some of the latest cloud offerings from Oracle, the iPaaS cloud offerings from Oracle, and to show you how effectively they can be utilized for a typical business use case. And this is going to be a continuation of Ling's session, where she introduced you the concepts of Oracle Integration Cloud, Autonomous DB and ORDS, and also the Oracle Functions as a Service. So in this session, the focus is more going to be towards the Process Cloud, the API Platform Cloud, and Platform Cloud and API, and also the Insight, Oracle Insight. So let's start. So we will start with the use case and design walkthrough. It's the same use case that we have used for the previous session. It's being followed by the overview and features of the Process Cloud, API Platform Cloud, and Insight. And then finally, we will have a recap in an attempt to remind you of all the things that we have covered in this session. So let's have a quick walkthrough of the use case and design. So in the previous session, if you remember, we started from the on-premise file server and the polling. The files were polled into the first integration, which is the file reader, and then the file reader processes it and then invokes a decision model. So the decision model inside the integration cloud decides whether this file needs to be corrected or not. And based on that decision, it invokes a process from the process cloud. And if the decision says there is no correction needed, and then it is going to be go to the direct integration 2, which is the DB writer. So inside the process will check the entries for which correction is needed, and then create a correction form, which is a web form, and then assign this correction form as a task to a human or an authorized user. And this human or the user can actually decide to work on that task. He can correct the entries, or he can decide to keep all those entries as it is. in case he decides which was correct, the original entries were correct. And then once the task is completed, the integration 2, which is the DB writer integration, or original one, will be invoked, and this one will write the entries to the database. And the database, as Ling explained, will be exposing ORDS layer, basically the REST services for these tables. And then these REST services will be called from within an Oracle functions, and then function eventually will be accessed from the API platform cloud. The platform cloud it's going to be the platform cloud's responsibility to expose all these services to the rest of the web or intranet. And then there is Insight, which is the asynchronous platform provided by Oracle to collect the business metrics and business data, and then provide business users with meaningful dashboards, including charts and graphs and whatnot. So let's start with the Process Cloud. Process Cloud, it's Oracle's business process management notation, BPM, and 2.0 based portal, which allows us to design and operate on human tasks. It is possible to create the process without a human task, but it's always advisable to use the process only when there is a need of human task, because all those things which can be done by the process can be done by the Oracle Integration Cloud as well. So it has two components, a design time, which is also known as the composer, and a runtime, which is known as the workspace. Design time is the UI, where we actually design the process, and the runtime is the task repository, where we can see all the tasks assigned to a specific user, and from there we can reassign, complete, or even delegate the task to another user. Let's go to the demo. So in this Oracle integration portal itself, you see the My Tasks and Processes, two different tabs. And when it comes to the Process Cloud, these are the most important tabs. Processes is the design time, and the My Tasks is the runtime. Let's go to the process. Let's go inside the process application, and let's open our process, which we have designed and implemented for this use case. You can see many different tabs, but for the sake of this presentation, let's stick to the basics ones so that we can cover the most important things relevant for this use case. Let's open the process. Let me zoom out a bit. Yeah, hopefully this is visible to all of you. If you pay attention, you can see two different swim lanes. This is in Oracle's terminology is called a swim lane, a process reviewer swim lane and a process owner swim lane. Basically, the application groups which can be associated with a number of users, a reviewer group and an owner group. And everything comes under the reviewer group can be taken by the users inside the reviewer. So if you see, the task is inside the process reviewer group, and that's why it's going to be get assigned to the reviewer. So it receives the messages from the integration, and the Process Cloud receives messages from the integration one, and then create a human task, and the human task will be processed by or submitted or completed by authorized user. And this authorized user can decide not to do anything. Instead, he can withdraw or suspend this particular task as well. So in case he decides to withdraw or suspend this task, the process is going to send a notification to one of the configured users. And this user can be a manager or an admin, anyone. And if it is completed successfully and the user corrected the entries, then our second integration, which is the DB writer integration, will be invoked from the process itself. So a nice integration between the integration cloud layer and process layer is already provided without the use of any external protocol invocation such as HTTP or SOAP. And that's the end of the process. And one thing which is worth mentioning here, in the properties of the human task, you can see a close association with the web form, which is known as the SOFA type web form. And I will try to explain it in the form section. So the form section provides us the capability to create and design and create web forms, which comprises of HTML and CSS. But the good thing about this is we don't have to actually code any of this. We can create business types, basically the models, which contains all these fields, and then drag and drop these business types into the forms palette, and Oracle will create these forms for us automatically. So it's a very nice feature. So if you see this particular form, we have marked number of seats as the desired field to be corrected with a red mark. Let's go to the task and see how this works. So if you see the My Task, I have two different tasks assigned to me. One of them was created previously, maybe an hour back. Yeah, and this one, you can see this is created 18 minutes ago, and this is the one which Ling created, or when it was created when she placed a file which needed correction. So the decision model decided that there is a correction needed for this particular file, and then it creates the task based on the process. So this is how the task looks. It has the form which we have created and associated with the task, and it has all the details of that particular file, which is file 14, and all the details, and then an entry for the correction. I'm correcting it, let's say 4, as per my decision, and then I'm submitting this. It's gone. You can see this particular task has been gone. And if we go to the processes, which is the monitoring of these tasks and processes, we can see this particular instance. And here there is a graphical representation of the task and the process flow as well. So we will be able to see, okay, this one is a previous task for which the human task has not been completed, and what we are interested in is a task for which the process is completed. Let me go to that again and show you. Yeah, so this is the one which we've completed recently, and you see the green line starting from the start into the task, and then the user decide to complete it with the correction, and then the furniture DB typewriter, which is the integration, is being invoked from the process, and then end of the process. So that's how it works, the process. Let's move on to the next one, which is the API Platform Cloud Service. API Platform Cloud, just like any other vendor, Oracle also provides us with all the features, bells and whistles, which is required for the API-led economy, and things which needed for the API monetization as well. You see a management console and a developer portal, both associated and integrated with API, which is the Oracle's documentation tool for the APIs. And then you see platform APIs, which is a group of REST APIs provided by Oracle itself, so that all the things which can be done by the management and developer portals can be done through the services as well, which is of a very nice use when we decide to integrate it with the Jenkins or any CI/CD pipeline tools. And then there is API gateways, which is the actual place where the APIs are being deployed and being monitored. And this API gateway can be installed in a Oracle Compute instance, which is part of this platform itself, or it can be deployed and managed from a third-party cloud, such as Amazon or Microsoft Azure. Also, it is possible to install and monitor these APIs in an on-premise environment as well. The installation directories and installation files will be provided by Oracle itself. It's just a matter of installing it within some 10 to 15 minutes and then make it run. So let's go to the demo and see this in action. You can see the API Platform Cloud instance for us for our use case, which we have created, and you see a management portal and a developer portal. Let's open both. And let's start from the development portal. So you see the development portal, it has a My Application tab, APIs, and plans. And APIs is the most important one. Furniture API, you see the documentation for the Furniture API. And this documentation is created using Apiary and then later integrated to the developer portal. And this integration can be done from the management portal, and which I will explain in a bit when I go to those slides. But now just focus on these two services, these two operations, list all furnitures and create new furniture types, which are under the Furniture API. And Apiary provides us the option to call these services or mock these services. Let's try that. So this is a mock service, meaning it hasn't implemented yet. And in case the developer wishes to integrate it to one of his applications, even before the implementation, he can decide to use the mock server provided by Apiary. Let's try the mock server for this one. Call the resource, you see, done. So all those, so anything which can be mocked in Apiary will be present here as a response. And now for the actual list all furnitures, which we have implemented in the functions itself, and the function is exposing this other service, and then later API management portal will call this function using a proxy. I will explain that, but before that, let's try to call this. And you can see a lot of responses. This is actually coming from the database itself, which exposed these table entries as a ORDS REST service. So all those responses you see here itself. And it is to be noted that this time it's being called from the production, which is the actual endpoint of this API or the service. So now let's go to the management portal. So this is how the management portal looks like. It has a lot of tabs. I would love to give you a walkthrough of all these tabs in detail, but for the sake of this presentation, let's stick to some of the basic points. Because that way I can cover a lot of the things which are relevant for this use case and this presentation. Let's start from the API. You see the API, Furniture API. Let's open that. The first tab you see is the specification and an association with API. If you click on that, you can see all the API documentations available in the API. Right now, I have created only one API documentation, which is the Furniture API, and that's how you see it. And you can click on this, and then it will be attached. That's it, that easy. You get all these documentations automatically populated. And then you have the API implementation part, which is of most importance here, because this is the place where we apply all the policies and all the routings and any kind of method mapping, which is self-explanatory. And you see here a service request. This is our backend service, also known as the business service in Oracle's terminology. And this backend service is actually pointing to our function. And this endpoint was exposed or is exposed by the function which Ling created and showed you in the previous presentation. And you see API endpoint URL, which is proxy. We can define any path here, and the HTTP will be listening to that particular path. And on the right-hand side, you see a lot of policies, and there are a lot of policies available to be applied on top of these basic implementation. Again, we won't be able to cover all of these because it will be slightly out of the scope of this presentation. So let's move on to the next one, which is plans. Plans basically which enforces the API monetization aspects of the API Platform Cloud. Here we can define the rates, how many requests per minute is possible, and we can publish this entire thing in the documentation section of the developer portal, and also the grants associated with these things. And then there comes application, which is a group of all these APIs for a specific app or a specific group of use cases, and which comes under an app key. And this entire application can be called with the help of an app key, which is again a common standard nowadays with the API platforms. And then gateways, which is the most important thing, because this is where we actually deploy our APIs in real time. We manage and maintain these APIs under the deployment section. And this particular gateway can have multiple nodes as a cluster. For this use case, we have created this API, gateway under the Oracle Compute instance. But just like I mentioned, we get the downloader from here, and this can be installed under any platform, any third-party cloud, or even a on-premise machine. And again, grants are possible for all different kinds of operations under this gateway. So let's move on to the next one. Insight. So Oracle Insight is the business activity monitoring portal and platform by Oracle, which is a unique way of creating dashboards with bars and charts and all kinds of user-friendly notations. It's basically intended for the business user because the actual technical user or a developer can get this information from within the tracking and tracing capabilities of Integration Cloud itself. But for a business user, it won't make much sense seeing those data. So it's for the business user. Let's go to this portal and see that in action. So this is an insight model we have created for our use case, and our use case is dealing with the files and correction of files. So you see many different dashboards. Most of them are created by Oracle by default when we create the model and associate it with an integration or a process with the defined key performance indicators. But we have to pay attention to this particular one. This is created for finding out the total number of correction required items in each of the files. So this is a very user-friendly way for a business user to see how many entries were corrupted in that particular file. So if you click on this, which is furniture type file 2, it's a clickable entry, and which will provide us all the details of this particular instance with the total number of items and number of items to be corrected and all those things. And most of these dashboards are like user-friendly, and interactions are possible, like a click or a hyperlink. We can click on this one. You see the number of files or transactions merged to the database. This is called a milestone in Insight's terminology. A milestone is like a kind of a stop we define in a process. Once the process reaches that stop or a stage, which will be tracked here. Let's see the model also. So we have defined two separate milestones for this process, once file received and once files are merged to the database. And that's why you see in the console two different milestones. But it is possible to define and implement multiple milestones as and when required, or if the business use case requires it. So that was about the Insight demo. And let's have a recap of our entire session, just an attempt to remind us of all the things that we have utilized from the Oracle offerings for this particular use case. This is our use case. We have started from the on-premise file server, if you remember. The on-premise file server will poll or attempt to poll from the on-premise machine. We place two files, one for which correction is needed and another one for which correction was not needed. And then there are two integrations in the Integration Cloud region, the integration 1 which reads the file and the integration 2 which writes the file. And integration 1 will call a decision model, and the decision model will decide this file is to be corrected or not. And based on the decision model's output, a process will be invoked if correction is required. And if the process is invoked, it creates a human task and assigned to a particular user or an authorized user. And the user can decide to act on this form, correction form, and he will correct the entries or decide to keep the entries as it is. And then the process will invoke the integration 2, which is the DB writer. And the DB writer will write these corrected or intact entries back to the database, and the database will expose all these entries as an ORDS layer or a REST JSON service. And this ORDS service will be invoked from an Oracle function, which is a function as a service, another offering from Oracle itself. And the main thing, a thing which is to be noted here is that it can be exposed to the API platform cloud even without the functions, but we have decided to keep the functions for the scalability purpose, because in future, if you want to make multiple calls or a number of calls, which can be like expensive, but on a function, Oracle function, it can be much cheaper when it comes to the costing and licensing part. And then we have the API platform cloud. We call these exposed function service from the API cloud gateways, and then it is exposed to the rest of the web or the intranet. And finally, we have the Insight. Insight is the business metrics and activity monitoring tool, which is an asynchronous tool which keep on polling for information from both processes and integration, and then help to maintain the dashboards created for the business users. So that's it in a nutshell. Yeah. So hopefully we will have some time to answer some of the questions that you might have. And over to you. Thanks for listening.
Thanks a lot, Viraj, Ling, and Pulkit for your introduction and your demo of the use case you made. Up to now, we didn't see any questions in the chat, but I do have a question for you. You have shown, well, I think a rather complex flow with a lot of elements. And I'm a little bit curious, how much time did it take you to develop this? Who of you can answer that?
Yeah, probably Ling and I can answer this best. Definitely it was not an integration in a week, but compared to the on-premises technologies and application platforms that we've used, it took us little time because most of the things were like a bit more user-friendly and already available out of the box adapters and all those things, which helped us to complete it, I would say, maybe 2 weeks, 2.5 weeks, Ling, if I'm correct.
Yeah, of course, not working full time on it, but between our work, well, just doing research, finding out how things work, and altogether it took around 2 weeks indeed. So that's not very long.
Yep.
No, because I think it was also a combination of developing this and getting to know this tooling and the whole environment, how it was working. And it was not that you already had experience and knew how to do it, but you could just learn how to do it in this in these 2 weeks. Yeah.
Yes, definitely. It was nice to work with this nice product, and we definitely learned a lot. Beforehand, we did not have a lot of knowledge on the product. So having an actual use case, exploring the capabilities Oracle has to offer, it was a good way to learn, definitely.
Yeah. Okay.
Yeah. Someone who is coming from the Oracle background, he might find it like really intuitive and user-friendly. But if someone is like more into the Mulesoft or Dell Boomi, he might find it a bit different compared to those platforms. That is something I have to say. But in overall user experience, in that perspective, it's kind of which is equal to Dell Boomi or Mulesoft, I would say, because I have exposure to those platforms as well.
Yeah. And I would actually like to add something here because we are talking a little bit about comparisons between different platforms. I've worked with AWS Glue. I've worked with AWS Step Functions. I've also did a small project with Microsoft Logic Apps. And so till the time, I think this is the most, let's say, capable integration product among all the publicly available clouds within the top 4 public cloud vendors. So I think that is also pretty big, plus point for OIC.